So here I'm going to cover the statistical aspects of meta-analysis. So this won't cover all of the parts that you have to do before in finding the literature, recording it, critically evaluating it, and determining its quality using the traffic light system. I'm going to use R as my preferred thing because it's quick and easy to do the statistical analysis, and it doesn't involve the complexities that you have with RevMan of putting in all the references before you can get started on the analysis itself. So it makes it much quicker for me to get to the point of showing you what an analysis looks like. But there's no reason why you shouldn't use RevMan. So first thing you need to know is what kind of data have you got? Have you got continuous or dichotomous binary data? Is it yes, no, true, false, or are there continuous things like blood pressure, amount of a specific measurement quantity that you're seeing if the treatment's been effective? You must be able to select the appropriate measures for the meta-analysis, and then we'll go through what the steps of the analysis are. So continuous data will include all measured data, including times, weights, lengths, volumes, exam performance, IQ, blood pressure, titer of microbiological measures, anything like that. They can be described with a mean and a standard deviation, so that's what you're looking in all of the papers that you're going to access. Dichotomous binary data represented as zeros and ones, could be sick and healthy, alive and dead, presence or absence, so that's what happens in COVID diagnosis, or true and false. Now sometimes you have continuous data, which would be the amount of virus present, but below a threshold you consider that it's no longer sufficiently present for that person to actually be carrying. Now that happens in microbiology as well, where you say that there is no contamination within the sample when it's below a certain threshold. So sometimes continuous data is interchangeable with dichotomous data. So when you want to collect and extract the data from the papers, if you're dealing with continuous data, you need to tabulate the means and standard deviations for the experimental and control groups. If you're collecting evidence from dichotomous studies, then you need to tabulate the number of people that are in the affected group and the number of those that are in the unaffected group in both treated and controlled groups. So this is a tabulation of continuous data from an analysis of hippocampal volume dependent on post-traumatic stress disorder. So what you've got the mean and standard deviation for those that have post-traumatic stress disorder and those that are outside that area, that don't have any problems. So for the first one you've got 1072 is the mean, and in the PTSD group with standard deviation of 779, and in the control group it's 1084 with a standard deviation of 599. It's also really important to have the n's, so the numbers within the study. Here's some dichotomous data where you're looking at whether they've got COVID or whether they've got a response to COVID or whether they haven't got a response to COVID. So this was the hydroxychloroquine study, where they just classified the people as having or not. What you need to do is collect and tabulate the data. Using Excel is fine to tabulate all the numbers. You want columns for your means, standard deviations, control and treatment group, and number, and the same within the dichotomous data. R will do all the summary statistics and overall effect size, produce the forest plot, also give you the funnel plots, and tell you about the heterogeneity of the analysis.